the task I was given here was to talk to you about the factors influencing soil organic matter content in urban disturbed soils. I am research director of the Consiglio per la ricerca e la sperimentazione in agricoltura, research center for agrobiology and pedology of Florence, and I'm also secretary of the European Society for Soil Conservation. You can find the website of the society here. There is also a Facebook page. I suggest you to have a look because the society gives the possibility to have grants. There is next year a conference in Italy, close to Bologna, and there are grants to attend this conference. And every year we have conferences with grants for a young researcher. As the issue there is soil conservation in a broad sense, and I think that you all are involved in this field of interest, I do suggest you to have a look at it. So, the outline of my speech this afternoon. I'm going to talk why soil organic carbon matters, the causes of variation of soil organic carbon in time and space. In particular, I will pass through the effects of land use changes, and then I will show you some result of a project financed by the Ministry of Agriculture, which is related to the monitoring of the soil organic carbon variation in space and time. And then I will show you some slides about the effects of soil management on soil organic carbon content. And finally, I will show you another experimental result about sensor-based monitoring to detect the effect of management variations in space and time. So, why soil organic carbon matters? You all know that soil provides provision and regulating ecosystem services relevant to major challenges area of climate change adaptation and mitigation. This is much on fashion now. These criteria have been formulated by different authors and also taken by the European Union and are at the basis of many European policies. So first of all, climate change is a major concern. Then there is food and energy security, which, as you can see, has been put at the second order, not at the first one. But actually, soil organic carbon is also important to maintain food and energy security. And then water protection is a major concern. Biotechnology for human health. From soils, you can get a lot of medicals. Ecological sustainability, and finally, slowing of desertification, which is one of our issues here. In all these functions, organic matter has a pivotal role. In that, nutrition, why it provides a source of nitrogen and phosphorus for plant growth. Biological functions are also very much related to the organic carbon content, and we have already seen that organic carbon content profoundly affects the activity of microflora and microfauna organisms. And then physical and physical-chemical function, in particular related to soil structure, thereby improving tilth, aeration, and retention of moisture, and increasing buffering exchange capacity of soil. In this slide, you can see what happens to a soil which has been sculpted because of excessive land movement, slope reshaping. The original soil was dark in color with some organic carbon content. The resulting soil was without organic carbon. The structure is completely destroyed, and this can be easily recognized by the steps on the ground. So, soil organic carbon, soil organic matter, is a key indicator of soil health. I have to remind you that solid organic carbon and solid organic matter are treated as a synonyms. Actually, there is almost an average ratio of 1.74 in between the solid organic carbon content and the solid organic matter content, which depends on the molecules of the organic carbon or the organic matter. So this role, this pivotal role of organic carbon has been acknowledged also at the European, at the continental level and worldwide, so that among the processes which threaten soil, decline of organic matter content is acknowledged as one of the most important ones. Actually, there is an insufficient content of organic carbon in the world as a whole, especially in the agricultural areas, and especially in Europe, and among the European countries. It's easily to be seen here. The countries placed around the Mediterranean Sea are the weaker in organic carbon content. In particular, in Italy, it has been estimated that at least 23% of Italian soils have less than 1% of solid organic carbon content. That means 1.74% of solid organic matter in the first 30 centimeters. This is an estimation made by the Joint Research Center in the year 2010. There are several other estimations, but they all range around these values. Why 1% of solid organic carbon? Because it is roughly estimated that this is a sort of threshold, minimum threshold of solid organic carbon content to assure basic soil function related to the soil function I've just showed you. But as you have seen in the previous picture, the solid organic carbon content is very uneven in space, and we will see also in time. And what are the causes of variation? For example, you can relate solid organic carbon content with lithology. And this is an example from Italy related to the National Soil Database. And you can see how significantly differ solid organic carbon content according to the lithotypes. The poorest lithotype is marine sediment, coastal and deltaic deposit, calcarenite, and residual soil deposit. By the way, just the lithotypes that are very common here in Apulia region. So in this environment, on this lithotype, you have the lowest soil organic carbon content. Then alluvial lacustrine deposit, clay formation, then effusive formation, sandstone, metamorphic schist, clay sandstone, Mars and Marley pellitic turbidite, and then lagoons and slope deposit, and finally calcareous and dolomitic rocks, intrusive and metamorphic non-schist rocks. So I ask you a question. What is the reason why, what is the rationale why we could find significant differences in soil organic carbon content on different lithotypes? Land use.
Vegetation cover.
Land use, vegetation cover. That means that on marine sediment, coastal and deltaic deposit, but also on alluvial and lacustrine deposit, you have more intense agricultural land uses. And it is very much related to soil organic carbon content. On the other hand, on calcareous and dolomitic hard rock, metamorphic rock, you have usually shallow soil, a lot of stoniness, a lot of rockiness, and this prevents an intensive agricultural exploitation. And on the other hand, let the soil cover be preserved, and so the organic carbon content. Of course, slope deposits have the problem of morphology. So in this case, is another soil forming factor which interact with the lithology and affect soil organic carbon content. So you have always to think about all the 5 soil-forming factors as a whole, not only to one at a time. Morphology, I have just tell you something. Also in this case, it is very evident that the steeper slope, the highest the organic carbon content, because the intensity of the land use is sure less. While on the other hand, on leveled lowlands, you have the lowest soil organic carbon content. So in this environment, which is close to the Mediterranean Sea here in Apulia, and almost leveled landscape, it's clear that the soil organic carbon content is one of the lowest in Italy. Then there is climate. In this case, things are a little bit different, in the sense that here you can see thermometric regimes, that means basically mean annual soil temperature, and odometric regimes, which means the amount of water in the soil control section during the time, from the driest condition, dry xeric, to the more humid, the UD condition. In this case, instead, you can see that there is a relationship in between the climate, and particularly the pedoclimate, and the soil organic carbon content. This is very easy. Why in thermic soil moisture regime, thermometric regime, and in dry xeric odometric soil moisture regimes, the organic carbon content is lower? I think that all of you know this. Sorry? Leader degradation due to biological activity. Biological activity is enhanced by temperature. To a certain extent, actually, things are not so easy because you need some amount of moisture for the microbiology to function. So, but and as a whole, in the Italian condition, humidity is not so limiting, apart from small areas where the microbiology cannot degrade the organic carbon. But as a whole, when you have an increase of temperature, the organic carbon content decreases. I recommend you, if you work inside the soil conservation issue, you must know something about soil classification, at least basic concept like soil moisture and temperature regimes of soil taxonomy, because are really so widespread and important for all of you that it is mandatory to know something about that. So now we come to a point where we can postulate that as organic carbon content is rather strongly influenced by climate, the climate change which occurred, especially at the end of the 80s in Italy, but is still going on, although there are some debate on that. But for sure, the climate has changed at the beginning of the 90s. Could have it played a role in the soil organic carbon content of Italian soils? For sure, you can see here that the mean annual temperature variation was, as a whole, in between this time period and this other time period, towards the increase of temperature, which was minimal in some part of Sicily, Sardinia, and central and southern Italy, and maximum in northern Italy and some part of southern Italy. But as a whole, there has been always an increase in temperature. In terms of mean annual precipitation, the variations were not so clear. I mean that there were areas where rainfall even increased, like in south of Spain, some part of Apulia, and even in Po Plain, but not so much. And there were some other parts where the the precipitation decreased, especially in the Alps and in the Apennine, just where the total amount was higher. As a result, we estimated the influence of this climate change on the soil organic carbon of Italian soils, and we found that there was some influence, but not so marked. Actually, there was an influence especially on meadows, so not arable land, and to some extent also to arable land, but not significant on forest, for example. And the area where the influence of soil organic carbon decrease was due to the climate change was rather limited to the Sardinia, the part of Sicily, the eastern part of Sicily, and some part just not far from here in southern Italy, and here also it was really important, the pre-alpine area and pre-Apennine areas. But what was really, really important was the influence of land use. The influence of land use type in terms of arable lands, meadows, and forests was very, very clear and highly significant. And this was not only confirmed at the broader national scale, but also at a more detailed scale in terms of a kind of land use. As a whole, the soil organic matter content in Italy is taking into account this 23,516 sites, 2.95%. And as you can see here, the threshold is just here, in between the arable lands and not arable lands. And the lowest values are on paddies, rice cultivation, then vineyards, vegetables, agriculture, row crops, olive tree, urban soils, orchards, and then in not arable areas like meadows, agroforestry, wetlands, and so on, it started to increase up to a maximum of 6% in woodlands. And as you take as threshold 1% of soil organic carbon, which corresponds to 1.7274 according to the authors, or 3.6, which is 2 times soil organic matter minimum content, you can see that most soil has, on average, 80% of this large population of Italian site has organic carbon content lower than 2 times the minimum, and 34% less than the minimum, which some land use, which can be also 48%, like for example vineyards, have 48% of cases where the soil organic carbon content is lower than the minimum. Another factor which affects very much soil organic carbon content in Mediterranean countries and in Italy is irrigation. This is the distribution of irrigated land in southern Italy. And as you can see here, the population is not so numerous like in the other case, because this was only used to compare irrigated and not irrigated crops. As you can see here, in any case, you have a strong negative influence of irrigation on soil organic carbon content, especially on vegetables, row crop, and to some extent orchard, while when you come to vineyards, olive tree, and other land uses, the differences is not significant. Why? Because many times when you have irrigation in tree crops, you can have what? Which prevent soil organic carbon decrease. Which practice can be introduced under irrigation when you have tree crops. A practice which is introduced not only to maintain the soil organic carbon content, but also to prevent soil from erosion, from compaction, from other mulching, cover crops. You're right. So when you have irrigation, under tree crops, many times in Italy you have cover crops, at least in central Italy. In southern Italy is also introducing, but it's not so widespread. And this is the reason why the difference in between irrigated and not irrigated crop doesn't have this strong effect on the organic carbon content. So, we also in this case try to investigate more in detail the effect of land use changes on soil organic carbon variation. And we choose 3 areas, 2 placed in central Italy and 1 in southern Italy, on the same kind of soil, but in different climates, just to see the interaction between land use change and climate variation. The kind of soil that was under study was vertic cambisol, which is one of the most widespread kind of soil under agricultural use in Italy. Vertic cambisol are a kind of soil which characterize the hilly landscape of Italy formed on marine deposit, clay marine deposit, where the clay is made up of smectite and other active clay, so that cracks forms inside the soil, and sometimes they go down in the substratum, like in this case, and there are many forms of soil erosion, mass movement. One important characteristic of the soil is the formation of cracks, which open during summertime and close during winter time, and then a lot of other features like self-mulching, wedge-shaped aggregate, and so on. It is a very typical kind of soil which is widespread in Italy, but also in other countries. So, first of all, we compared this kind of soil in 2 different basins. This is the Valdera Basin, and this is the Valdolcia Basin. These 2 river basins correspond also to different marine basins. So the clays here are a little bit different from here. And the third place was in Calabria, in southern Italy. The soil was the same. The mineralogy also here changed a little bit. But what was really different was the climate. And comparing the 3 main land uses, which are forest in form of Mediterranean macchia, meadow and cultivated arable land, you can see that there is a significant difference in terms of organic carbon. The forest land has a richer organic carbon content than the meadow, than arable land, and this is the variation along depth. So the main variation are limited either to the first 30 centimeters under forest land and only 15 centimeters under meadows, while below the arable land the low organic carbon content is uniform along depth. Then we also studied microbial biomass, so biology, and you can see that the trend is just the same. The microbial biomass is higher under forests and meadows, although the differences are not so pronounced than as for organic carbon content, while the agricultural land use is the lowest with a uniform trend along that. And also the humification, the degree of humification. Humification means the formation of humus. Okay, the organic matter is not the same inside the soil. It's a complex system which is formed by different kinds of macromolecules. The most organized one, the most developed one, are the humic fractions. So, in brief, things are a little bit more complicated, but just in brief, the degree of humification means the degree of development of the organic carbon content in the soil, and also the stability, the resilience of the soils against perturbation. And so, as you can see here, the highest degree of humification was under Mediterranean macchia, forest, and meadows, while the lowest under wheat. Although also under wheat, there is a little bit more humification in the upper horizon. Finally, we try to estimate the changes of soil organic matter caused by the change in land use, because we studied fields which were close with replication, of course, close one to the other, like in the pictures. Maybe I forgot to tell you. This is the picture where the study was done, for example, here in Valderia. So there are different land uses, one close to the other, and the variation caused by the land use change was always very significant, and especially higher in the transformation from forest to wheat or forest to meadows in all the three environments. But as you can see here, the highest variation was in Calabria, Soveria Simeri, which had the highest temperature and the lowest rainfall. So, what does it mean this? That when you have a land use change, the consequences on organic carbon content are not the same. They depend also on the kind of climate. And under stronger Mediterranean condition, the decrease in soil organic matter content is harsher than when you are in milder Mediterranean condition, the soil being the same. And this introduces us in another concept of soil resilience. What is soil resilience? Maybe you have heard of it. It's the capacity of soils of turn back in the original condition when it has been disturbed. Okay, you have already been introducing this concept. This study case is in Tuscany, but is to some extent similar to what have you seen in Puglia and in Sicily, because although in this case we are dealing with heavy mechanical treatment of the soil surface to plant a new vineyard. In this case, they don't grind the stones, but they only use this backhoe tractor, which has this kind of huge sieve, and so you have a certain sieving of the coarser piece of rock, which are put away from the soil surface. And we compared two vineyards which were placed on the same kind of soil, but they had a different age. One was planted in the year 2010. This one, this is the appearance of the soil surface just after the works I've shown you before, and this other one planted in 1995, that means 15 years before, and which was treated with grass cover and not grass cover. And we try to investigate, the trial is still going on. We are trying to investigate how long does it take to recover the original condition, or at least conditions which are similar to the other vineyards which was planted before. I have to tell you that actually in both cases we are not dealing with vineyards which were planted on a pristine condition. I mean that agricultural land here have been utilized for centuries, so it's completely nonsense to speak about pristine condition. So we have every time to make a balance according to the previous crop, not we cannot compare the soil with the pristine one because it doesn't exist anymore. So these 4 plots, 1, 2, 3, 4 belongs to the new vineyards, 5, 6, 7, 8 belongs to the old vineyards, and you can see in the year 2011 2012, which are the first 2 years of experimentation, the changes in the number of arthropods in insect in the soil, total insect arthropods, I would say, not only insect but also mites in the soil. And of course, in the year 2011, the arthropods contents in the first vineyard was extremely low, almost nil, almost desertified soil. But the differences in between the 2 young vineyards start to become less evident, just coming from the second year. And these differences here are in between the grass cover and not grass cover. Grass cover and not grass cover. What does it mean? That when, as the second year of experiment, when you compare the number of arthropods of the new vineyard with the number of arthropods in the old vineyard, they are comparable when you compare the bare surface, but are still different when you compare the soil with the grass cover. So that means that in this case the land management plays a prominent role, more than the new plantation activity. There is also this other index of biological diversity. This is 2011. This is the QBS, biological quality index, based on arthropod, like the Professor Calabrese showed you this morning. And also in this case, you can see the difference in between the 2 vineyards, both in terms of QB and number of taxa, which is very prominent in 2011. But just starting from the year 2012, this year the results are not elaborated yet, but just starting from the year 2012, you have a recovery of biodiversity, and the main difference is due to the grass cover, not to the anthropic works. So this new is relieving, at least in this environment with this kind of climate and kind of boundary condition. It is very important that here the vineyards are not too big and are intermingled with the forest end. I think that this makes a difference. So the boundary conditions here are very different from the boundary condition in Apulia region or in Sicily, and this makes the difference in my opinion, but we have to demonstrate it. So, all these things let you understand that organic carbon content in soil, that is organic carbon stock in soil, changes with time. This is very relevant because you know that most Western countries signed the Kyoto Protocol, and they are obliged to follow the organic carbon variation during time and to compensate the organic carbon produced by different sources and dispersed in the atmosphere with several other measures. One of them is related to the sequestration of organic carbon inside soil. And this is very relevant because if we can demonstrate that according to the measure that has been put in practice at the national level, we can compensate, and so we don't have to pay for the carbon emitted by industry, for example, or by other sources. So, as you can see here, in this time-lapse analysis, we have a strong decrease in carbon stock from this decade to this other decade, which correspond more or less to the climate change. So it could be also related to some extent to the climate change, but I'm not so convinced. And we have a recovery starting from the year 2000. And this is for sure, or at least it's very probable, that this recovery was due to the introduction of the so-called agro-environmental measures, which were funded by the European Union and passed through the national government and then to the regional bodies, to the outside. Sorry?
At what depth?
This is yes, this is up to 50 centimeters. So, to monitor the soil organic carbon variation in time and in space, you can follow different strategies. The most forward is the periodical sampling of benchmark site, but unfortunately this is not the case of Italy like in most other European countries. Only few, I would say a couple of or 3 European countries have a network of periodical sampling of benchmark site. So you can follow different strategies. And under this project that I mentioned to you before, we followed 2 other strategies. One was the so-called space for time sampling. That means we follow the climate sequences in the space just to replace the time variation and so the possible influence of climate changes with the variation in space which are found in the territory and due to the variation of climate related to morphology, for example, distance from the sea or latitude and so on. And the second strategy we followed was the resampling of legacy data. So we went another time to sample soil which were sampled in a former time, but for different reasons, not according to a specific scheme, just related to the periodical sampling of benchmark sites. So we performed this activity to identify threshold values of climatic indices, able to separate a significant soil organic carbon variation in space and time in the framework of 4 typical Mediterranean cropping systems. As I showed you, we cannot generalize too much of the information because the influence of land use and land management is crucial to understand the causes of variation. The final aim was to map the areas most sensitive to past and future climate change, which was the request we got from the Ministry of Agriculture, because you know that every European country has the obligation to produce a plan of mitigation measure to face the climate changes which are supposed to occur in the future. So we used the national grid of climatic parameters, which is 30 by 30 kilometers, with monthly values from the long period of 1960 to 2010, and we downscaled this information to 1 kilometer grid by means of geographic technique, and we split the long-term climates in two periods, into 30-year periods, 60, 90, 80, 2010, and we used the Marton index as a reference climate indicator. I will show you what is the Marton index, but in brief, it's just the relation in between temperature and precipitation. The four study areas were selected, one in the Po Plain and pre-Alpine area, which, as I showed you before, is one of the areas which is supposed to be affected by the climate changes. Another one was this one, which was also in theory one of the more sensitive areas, likewise Sardinia, and also, on the contrary, the western part of Sicily, which resulted, to the first estimation, the least affected by climate changes, because, as I showed you before, the climatic values says that the precipitation slightly increased, the temperature remained more or less the same. And these are the other variables which were used to downscale the national climatic grid. So, in brief, we also surveyed another time 147 places where we already had data about the solid organic carbon content, and then we elaborated this index, which is the delta C solid organic carbon, minimum detectable differences. This is important below the statistical point of view, because to say that a difference is statistical difference, you have to perform a certain statistical approach. The cropping system we investigated was the row crops and forage rotation, which is very much widespread in the Po Valley, pre-alpine areas, on a specific kind of soil, which is chromic alluvial loam. Maybe you are not so familiar with this kind of soil, but it's a sort of terra rossa soil, but not the Mediterranean, which has a clay increase in the profile due to lessivage and a certain reddening due to the weathering of primary material and release of free iron. So a certain kind of soil and a specific kind of cropping system. In Campania, which is in the region close to Naples, here, we investigate another kind of soil, which is endosoil, that is a soil formed from volcanic ashes, and the cropping system was the olive tree growth. And this is the extent of this growth system. Actually, it's not so widespread and dominant in the area like the previous one. In Sardinia, we investigated another cropping system, permanent meadows. Claudio Zucca also came with us to survey this kind of soils, which is rather widespread in the island. and the soil in this case was also chromic luvi soil, but sandy loam, that means with a different particle size. And finally, in Sicily, we went with Professor Dazzi and his collaborators. We investigated the cropping system of cereals and the calcic vertisoil. So a soil with vertic properties more pronounced than the other one I just showed you before. So we first of all checked if actually there have been also in this part of the Italian territory relationship between organic carbon content and climatic indices, and we found that actually the Demarton index was the most closely related to soil organic carbon, more than the simple annual precipitation, annual temperature, aridity index, or also the soil aridity index of the moisture soil, the mean soil temperature. So we choose this index to relate the soil organic carbon with the climate. And we checked the relationship of this relationship in the full cropping system, also in a statistical term. And as you can see here, as long as the Demarton index increases, also the soil organic carbon increases. That means that as the index of Demarton is the ratio between precipitation and temperature, so you have more organic carbon when you have more precipitation related to temperature. This is true in Campania, in Po Valley, in Sardinia, and also in Sicily. So you have always the same trend. But what is different is the threshold. I mean, when you have a difference in between the two clusters of Demarton index, which correspond to significant differences in soil organic carbon content. In this case, we could find this threshold in the Po Valley and also in the Campania region, in Sardinia, and in Sicily, so that we could see, okay, when we see that the Demarton index changed, we could expect also variation in soil organic carbon content of our studied soil. And so we compared now the variation in time. Before we compared the variation of climate in space, now we compare the variation in time and the relationship with then the soil organic carbon content. First of all, you can see that in terms of precipitation, temperature, as well in the Demarton index, you have a significant variation in Po Valley, Campania, and Sardinia, but not in Sicily. I mean, there was a variation in Sicily, but only in terms of temperature, which slightly increased, but very little, from 16.5 to 16.9. But as a whole, the Demarton index was not different, while decreased in these two time periods significantly in the other places. So we also try to investigate the mean annual temperature trend, so not only in terms of two time periods, but according to the different years. And you can see that the slope of the trend is rather similar in the different areas as for the temperature. But for the precipitation, the slope was a little bit different in Sicily. You can see here you don't have slope, so that you don't have significant climatic variation in time. This allowed us to map the areas where you had changes in time which potentially affected changes in organic carbon content of soil. This is the situation in the first time period, and this is the situation in the second time period in terms of the Martor index. I remind you that the higher values, the moisture conditions. So that means that you have a drying of the areas in the Po plains, which was particularly important in the pre-alpine area. Another time we confirmed this trend. And so we could see that the most sensitive areas were this one red colored, which are just close to the pre-alpine areas. In Campania, we had a similar trend, and so all the area cultivated by olive tree on this kind of soil, andosol, were found as being sensitive to climate changes. Similar in Sardinia for the western part, but the eastern part was less affected. That means that the most sensitive area to climate changes are the western part of Sardinia, while the eastern part have a less sensitivity. While in Sicily, we don't have any sensitive areas. Now we pass to examine the result of the validation with this graph, which put in relationship the soil organic carbon content in the three areas and the Demarton index. And we could see that in the two time periods, the relationship remained the same. That means that the mechanism is always the same. Nothing changed in the causes of organic carbon variation related to the climatic variation. We could have hypothesized that there was an external factor which influenced on the relationship in between climate organic carbon content, but actually it didn't occur. So that we could elaborate the minimum detectable difference in between the two time period, but as the variation inside the new sampled site was rather high, we couldn't see any statistical significant variation. What does it mean? That we actually could see climatic variation. We could see that there were climatic variation in space which affected the organic content, but when you sample the site another time at a certain time distance, the variation occurred in the same cropping system, probably due to land management, was so high that you cannot attribute the variation you see to the change in the climate condition. Anyway, we were rather satisfied from this experience, although we have to do another survey to enhance the number of soil which have been sampled. because we could demonstrate that there are actually climatic thresholds along chemosequences which correspond to significant soil organic carbon variation. So we can confirm that there is actually a relationship at the local scale inside a certain cropping system in between climate and soil organic carbon. And this variation are different in each cropping system, are not the same, although the mechanism you have seen is the same, so the relationship between climate and soil organic carbon is always the same, but the thresholds are not the same. And the most sensitive soils so far resulted the vitric undersoil of Campania. So this kind of soil is most sensitive. This is a very, very, very important information because usually most people think that the influence of climate on organic carbon content are only related to the kind of land use, land management, but we demonstrated that actually the kind of soil play an important role. So there are soil which are more sensitive to climatic variation and other soils which are less sensitive to organic carbon variation and climatic variation. That means that you have to know the soil you are studying before making assumption in this issue. And this is very important because as a role you cannot see many soil classification, soil typification in this kind of studies. And so far it results that soil organic carbon variation are less than pronounced that climatic variation. That means that something happened during the time which buffered the influence of climate on soil organic carbon. Probably was a tuning of land management of the farmers according to the climate, but we still don't know that. Now I want to introduce another issue. As I told you, the climate is important, land use changes are important, but land management probably is the most important thing. So that means that if you have the same climate and the same land use, if you treat your soil in a different way, you can have a significant different result. And I just quoted this statement of Ratan Lal because you can see by yourself, he underlines, he stresses the importance of soil management, which is on the basis of the most important global issues at the moment. And this introduces an important topic, which is conservation agriculture. Agro-environmental measures, I mentioned it before, have been introduced in different times in the European policy. Nowadays, there is a strong interest in the introduction and diffusion of conservation agriculture. What is conservation agriculture or sustainable agriculture? It's a set of practices which are addressed to the maintenance of soil quality, as already introduced the concept by the colleague this morning, Professor Calabrese. For example, one of these measures is crop rotation. Crop rotation can increase organic matter content, lower fertilizer need and groundwater pollution, and reduce runoff. The presence of cover crops and stubbles also is comprehended in the concept of conservation agriculture, because the maintenance of crop residues on the surface protects the soil from impact of raindrops and runoff. Also, conservation tillage is included in the concept of conservation agriculture, which means that we must try to avoid the inversion of the soil layers or the fragmentation of the soil structure as much as you can, with reducing the tillage with different techniques which reduce the impact of the mechanic instrument on the soil. This is a very well-known picture which shows you the effect of the better soil structure condition on soil infiltration. You can see here 35% more infiltration under zero tillage rather than under conventional tillage. And in case of heavy rains, this makes this huge difference. And then also on runoff, under moldboard plow, the soil loss is much higher than under chisel, disc, rotary till, rigid, or under no till, which is the lowest, which has the lowest soil loss. Then there are many other practices like grass cover, waterways. This is a nice example of water blade, buffer zone, like this way. This buffer zone means a trait of the field which is not cultivated, just to let it covered by vegetation, so that the river stream here, the stream or the river here, is protected from the pollution coming from the fertilizer or pesticide spread on the cultivation. This is in vineyards in Italy. You can see here the not only the grass cover but also the seeding of legumes, just to improve the soil fertility. Then there are other practices like those introduced before by Professor Tassi that are addressed to breaking the slope and reduce the soil erosion by means of interconnected threads. Like in this case, you can go from this thread to this other with the tractor, or terraces like in this case. All these practices, like also counter cultivation, which reduces runoff and enhances water harvesting, are under the concept of conservation agriculture. And this has a number of positive effects on soil physical characteristics. You can read by yourself. Chemical characteristics and soil biological characteristics. So the convenience of the introduction of conservation agriculture is in many cases recommended. Although there are recent studies which say that actually in certain kind of soil, which are unfortunately rather diffused in Italy, which are compacted soil, possibly in clay, rich in clay, the introduction of no tillage or reduced cultivation can cause several drawbacks. But in general, it is assumed to be very positive.
Sorry?
See?
Do you mean vertisols?
Vertisols, no. I mean not compacted soils like vertisols, because vertisols actually are dynamic soil, which actually, if are well preserved, well treated, can be also suitable for conservation agriculture. I mean regosol, clay regosol. I mean soil which have clay texture or even loam texture, silty textures, but which lack of structure. We are not dynamic and tend to compaction.
And what about soil piping then?
Soil piping also is not so much recommended, because if you have a lack of microporosity inside the soils, the water flow is prevented by this lack of interconnected macroporosity. It's not a question of lowering the water table. Pipe drainage is recommended especially to lower the water table. more than increase the permeability of the above-lying soils.
And how about the pollution of the no-tillage? We are talking about the structure of the soil, but the no-tillage requests a lot of herbicides.
Yes, this is another main concern, and actually I can tell you that I remained rather impressed when I was in Australia and at the conference of the International Union of Soil Science. One of the major keynote lecture was given by a producer of a pesticide, of a herbicide, and he was clearly in favor of minimum tillage because this meant the use of pesticide, and he was totally against the use of carbon biochar because the introduction of biochar prevented the effect of herbicide. If you give biochar in the soils, biochar sequestrates the herbicide, and so the herbicide is no more much effective. And so it was really clear to me and to many others that his speech was very much commercially biased, not scientifically objective. But this is true. Maybe there are many companies which support the introduction and diffusion of conservation agriculture. But scientifically speaking, I would say that conservation agriculture is a good thing. Also, the reduction of soil tillage can be a solution in some kind of soil, in some kind of pedoclimatic condition, with a certain set of practices, not one practice alone, but a set of practices which are very well tuned and combined one to the other. You have to comment?
Well, no, ICARDA is also working on that. It should be site-specific. They have large areas in Brazil that they practice no-till, but you are in more humid environment, and the soils are rather different with what we may have in the Mediterranean environment.
Yeah.
But no one would argue, at least for two of the three components that conservation agriculture require. So, rotations, and we badly need rotations, specifically in the Mediterranean. Then maintaining always a cover on the crop. Never leave the soil bare. No one could argue on that. As far as tillage, ICARDA is doing work. In Morocco, they have an experimental site. And not necessarily that they are, or in Syria, before moving out of Syria of the war, not necessarily totally no-till. They're experimenting with a new type of plowing, or better say phraser.
Cultivator.
A type of cultivator that do not break down the whole soil up to 30 centimeters and destroying the soil structure, and in that case also in our environment accelerating mineralization of the organic matter, but using some kind, they have developed, I was in a meeting in China and they showed this quite interesting presentation with a new type of tractor that farmers, by the way, were very reluctant because they used to plow every year, and but they experimented in small fields, this new machine, and apparently works well. But it has to be, again, site-specific. This we should remember. There is not a universal law that applies equally the same everywhere. You have to be very careful on the specific local conditions that each country or each region has.
Yeah. One of the major drawbacks of the introduction of conservation agriculture, even according to FAO, which is one of the most important supporter of this practice, is that actually the benefits are not at short time. They are at the medium or the long run. So for farmers who must live year by year, it's a sacrifice that they have to bear before seeing the result of the introduction of conservation agriculture. So, in any case, there is the need to monitor organic carbon variation due to changes in management. So we have seen that land use is important, but land management is even more important. If we want to introduce new management techniques, we have to monitor the effect. And we are trying to introduce spatial interpolation with the use of soil proximal sensing. I'm going to show you some first result of this new technique we have introduced in monitoring organic carbon variation due to changes in management. Here we are in Sicily, and we compared conservation agriculture, just I was introducing before, which is in this case green and organic manure, shallow plowing, crop rotation. This is the set of practices which form the concept in practice of conservation agriculture in this place, which are financed by the local authority. Okay, and we compare that with traditional farming: no rotation, mineral fertilization, deep plowing. And these are the two soil surfaces compared one close to the other, just to let you see how the appearance of the two soil surface is. But you can see here, this is the bio treatment, and this is the conventional treatment. So as you can see here, the result in terms of yields are not so nice. But in terms of organic carbon content, for sure, yes. And we analyzed organic carbon by laboratory method. This is a traditional farming field, and this is the conservation agricultural field. They are close one to the other, the same kind of soil. But also we analyzed organic carbon with a new methodology, which is rather new, not brand new, but not so widespread technology, which is spectroscopy in the visible and near infrared, just to enhance the number of samples that can be analyzed, because it's a quicker methodology than traditional analysis of organic carbon in laboratory. This spectrometer we use is this one, and it gives you a spectrum, which is a sort of digital signature of the soil characteristics, and can be related to several soil parameters, among which there is also organic carbon, but there is also clay, calcium carbonate, sand capacity of the soil, and iron oxide. Why? Because the wavelength of the instrument is related to these different characteristics. This is the wavelength related to iron oxide, color, organic material, mineral, water, carbonate, another wavelength which is related to organic material, and also another wavelength. So it's a complex system which has a different relationship with several soil parameters which are of interest. So we have every time the need to calibrate the relationship in between your target soil parameter and the answer given by the spectrometer. So in this way, we could have 30 samples analyzed in the two study fields, 15 with the new method and 15 with the traditional one, so that we had a density of 5 samples by hectare. What is really new in our approach is that we combined this approach with the gamma ray spectroradiometry. Gamma ray is a natural emitted radioactivity from the soil, from this radionuclide, 40 potassium, uranium-238, and thorium-232. This instrument, which is, by the way, also portable, or can be attached to the tractor, detect the total counts emitted by the 3 radionuclides and by each of them. And the correlation model is strongly site-specific also in this case, but can be also used for organic matter among the other soil parameters. So, by using the point result and relating them with the gamma radiation and spatializing the result with the geostatistic, in this case ordinary clipping, we could result with a spatial distribution of organic carbon in the two fields, which is really relevant, because instead of comparing single point in pairs, for example, in the two fields, we could compare the whole field in terms of the target variable, in this case organic amber. This is very relevant because we could assess that the traditional farming field had 33.2 tons by hectare of organic carbon, while the conservative farming field had 36 tons by hectare. So you don't need any statistical analysis because we have the whole population under control. This is the traditional one. This is the field under conservative farming field. So you can see, okay, in this case, the introduction of the agro measures are effective. And another very interesting result is that you have also the variability. And in the traditional farming field, not only you have a lower mean value, but also a higher heterogeneity inside the field. While in the new farming system, in the new management system, the result was not only higher in terms of organic carbon, but also 2.8 tons by hectare, but also the result was more homogeneous. So in terms of the effectiveness of the practice, you can say, okay, in this case, it's good for both the content and the homogeneity. Yes, please.
This image is after the cultivation or before or during the cultivation, because the even plants can absorb some soil matter.
No, you know the organic carbon is not absorbed by.
I know that.
By, okay.
It's a good thing, no? Yes, if there is the mineralization for the plants, it's good. For you, it's not good. You are talking that is more soil organic matter is better.
Yes.
Yeah, but for a cultivation, it's not like this, because if there is some nitrogen available, it's better. Because
yes, of course. But we are just speaking about the effectiveness of the introduction of this measure on the organic carbon content. This is our hypothesis. Then you have
with the period of this comparing with the plantation. It's not important.
No, of course you have to try to compare soil in the same stage of cultivation. It is better if you compare the two kind of the two soil under the same stage of crop cultivation. But this is another issue. I would say this is more a statistical representativeness of the sample. In fact, we cannot say as a whole, that introduction of this practice is positive. It was positive just in this field, but then we have to replicate this measurement many times. We had already done 10 replicates. We are planning to do other 10 replicates just to check this behavior in different conditions, because you cannot say yes or not based only on one comparison. But in any case, what is really relevant to us is the methodology to assessing that. Instead of comparing one point to another point, placed inside the field or specialized just with kriging no more, we related this specialization to a physical determination of the spatial variability, which was detected by means of the gamma radiation. So this is the novelty of the approach. Then you're right, you cannot generalize the conclusion. You have to check the stage of cultivation. You have to check everything, the fertilization and so on. But here, what is relevant is to see if actually, if you have an introduction of a new management system in the same cropping system, what happened? It is positive or it is not positive? Because this is also at the continental level a huge question, because every year the European Union finances a lot of money to introduce support this agro-environmental measure, but then the European Union doesn't know very well if the practice was correctly introduced, was effective or not. And so these kind of results are much needed also for policymakers. This was the main aim of our studies. Then you have all the rest that you are talking about. So, if there are any other questions, please.
When you show the map of Italy with this increase of soil organic content during the last decade, I said that it's because of the new policy agriculture.
It's an assumption.
Can it be related with the abandonment of agricultural lands and the forest area grow on this land?
It's a good question. It's a good question. Actually, this could have played a role, because actually we could observe an increase in forest stand, and so for sure also the increase in acreage of forest played a role in the increase of organic carbon stock in soil. You're right. This is another reason. Of course, you cannot attribute one macro phenomena to only one reason. It's stupid. There are several of them. I was just introducing this as propedeutic to the fact that in the framework of agricultural land, but to some extent also in forestry, the management is much important, almost like the change of land use.
Yes.
Can I ask a question?
Yes.
On that last slide before this one,
Yes.
like the two models, did you do like a reading before you start cultivating and then during the cultivation, like a start point? Or are those terrains that are cultivated like this for a long time?
No, this is also a good question. Here, the year of cultivation has not been reported, but this is the result of, if I well remember, 5 or 6 years at least of an introduction of the new practices. So it's not an immediate result. Sorry?
You don't have like a Euro zero situation?
No, we don't have in this case.
Subtract both of them and see the differences and.
Well, the zero actually is the traditional. because the traditional is assumed to be in equilibrium with the past.
Select like the same area on both of them and subtract them and see the real differences on the same area.
Yes, we could do in the future. It's a good suggestion. I thank you. We can try to see if it is possible to do this.
Well, if there are no more questions, we can give a hand to Dr. Costantini. Thank you very much. We had quite an intense day today, giving you as much information.